Hi everyone, my name is Wei from ANU. I would like to introduce our work, Weakly Supervised Action Transition Learning for Stochastic Human Motion Prediction. This is a joint work with Miao Miao and Matthew. In this paper, we propose a new task, action-driven motion prediction. Given an observation shown in pink and a sequence of action labels, this task aims to predict future motions that respect these conditions. Our insight is that human motions are always encoded by a sequence of actions. Enabling computers to produce motions that follow certain action sequences are important for applications like crowd animation. Previous motion prediction works, for example, DILO, cannot predict future motions that respect a specific action category. Although action-conditioned motion synthesis methods can produce motions of certain action, they cannot model transitions between different actions, which is a main focus of our task in this paper. There are two main challenges in our task. The first one is that there are too many possible action transitions to be covered by any motion capture dataset. The other one is that motions can have a variable length. Although in natural language processing, NLP, a stop token is often used to account for this. Such stop token does not exist in human motion. So that, in this work, we propose two simple strategies to tackle these challenges. We first introduce the weakly supervised action transition learning, which enables our model to be trained with datasets of single action motions. And we also propose a simple padding strategy for variable length prediction. Specifically, given a motion of single action like drink, we first augment it with motions from other action categories such as pass. Since the transition between these two motions are unknown, we then encourage the transition part to be smooth during training. For variable length prediction, we pad every training motion with its last pose to encourage the model to produce static poses after finishing an action. We can then stop predicting whenever static poses are produced during testing. Our model is a conditional VAE. During training, apart from the standard reconstruction loss and KL divergence term, we also have our smoothness prior for the action transitions. We explore two different temporal encoding structures to construct our conditional VAE, recurrent neural networks, RNN, and the transformer. We evaluate our model on three different datasets, GRAB, NTU13, and Babel. We mainly use three metrics: action recognition accuracy, which measures how well the predicted motion respects the given action label; visual inception distance, which indicates how realistic the generated motions are; and the diversity, which is the pairwise distance between the predicted motions given the same action label and observation. Here we show quantitative results. In general, our RNN-based model performs the best. We also provide qualitative comparison on these datasets. Baseline models either produce discrete motions, such as action to motion or actor, or predict future motions that does not reflect the given action label, such as DILO. Our code will be available on GitHub. Thank you.